how in the world do you predict the future of something as huge and complex as the energy industry? I mean, you could look at market trends, sure, or new tech, but what if I told you there's another way? You could look at its homework. And that's exactly what we're going to do today. We're going to figure out where energy is headed by looking at the skills its pros are scrambling to learn right now. So our guide for this little investigation comes from the training programs at Senergy, a major engineering consultancy. And this quote from them just nails it. It says, "They're equipping professionals with critical skills needed to lead in a rapidly evolving world." Those are the key words right there, critical skills and rapidly evolving. It tells you everything you need to know. The industry is changing, and it is changing fast. So that leads us to the big question, right? What exactly are those skills? And more importantly, what can they tell us about where energy is going? Think of us as detectives. The skills are the clues, and they're going to help us map out the future of this entire industry. All right, let's get into it. The way we're going to do this is pretty cool. We're using a course catalog as a kind of barometer for industry change. You know, like a weather forecaster uses a barometer to see which way the wind is blowing. We're doing the same thing, but for the entire energy landscape. I mean, think about it for a second. Companies don't just throw money at training for fun. They're not going to spend a ton of time and cash teaching skills they don't need. So this list, it's a direct signal from the market. It's basically the industry telling us, hey, these are the problems we need to solve right now, and these are the tools we need for tomorrow. Okay, so before we can really get a handle on where things are going, we've got to understand where they've been. Let's start with the absolute bedrock, the foundational skills, the stuff that's powered this industry for, well, for decades. And right at the heart of all that is something called reservoir engineering. Now, what is that? Well, in the simplest terms, it's the science of understanding this giant rocky sponge that's buried deep underground. The goal is to figure out the absolute best way to get oil, gas, and other stuff out of it, and to do it safely and efficiently. And you can really see just how deep this science goes when you look at the courses. You've got the basics, right? Fundamentals of engineering and simulation. But then you get into the really advanced stuff, like enhanced oil recovery. That's basically the art of finding super clever ways to squeeze every last drop out of oil fields that people thought were totally tapped out. This is the kind of core knowledge that's been the engine of the industry for ages. But here's the thing. Knowing what's inside that rocky sponge, that's just step one. The next huge challenge is, okay, how do you actually build the massive, incredibly complex systems needed to develop an entire field? It's a whole other level. And this is where the engineering just gets epic. We're talking about courses on strategic field development and lifecycle management. This isn't just about building a rig. No. This is about managing a multi-billion-dollar project from the very first survey of the rocks all the way through decades of operation and then safely shutting it all down at the end. The scale is just mind-boggling. It is a truly colossal undertaking. So there's our foundation, right? Deep, deep science about what's underground and massive scale engineering to get it out. But this is where our story gets a major plot twist, because the world is changing, and that means the entire mission of the energy industry is changing with it. Yeah, the goalposts have totally moved. It's not just about extraction anymore. The new mission, the big goal, is building a sustainable energy future. And to do that, you need to take all those core skills we just talked about and point them in a brand new direction. And a huge piece of that new future is a technology you're hearing more and more about. CCUS. That stands for Carbon Capture, Utilization, and Storage. Think of it like a high-tech toolkit for grabbing carbon dioxide, CO2, right from a power plant or factory before it gets into the air. Then you either find a way to reuse it or, more commonly, you lock it away for good, deep underground. It's basically a three-step process. Simple, right? First, you capture the CO2 where it's being made. Step 2, you transport it, usually by compressing it and sending it through a pipeline. And then step 3, you store it. You inject it deep down into the exact same kinds of rock formations we've been talking about, where it can stay locked up pretty much forever. Okay, now this right here is the absolute heart of the story. This is the whole point. We're not talking about throwing away the old skills, not at all. We're talking about repurposing them. That same seismic data that was used to find oil, now it's being used to find the perfect, safest place to store CO2. Those complex computer models built to get every last drop of oil out, now they're being used to make damn sure that CO2 stays put permanently. It's the same expertise just pointed at a completely new and vital target. All right, so we've got the core science and we've got the new sustainable mission. But there are two more layers to this, two massive forces that are basically acting like rocket fuel for every single skill we've talked about so far. They're the great accelerators. And the first accelerator is probably no surprise to you. It's data. You've heard the phrase data is the new oil, right? Well, in the energy sector, that's literally true. The whole industry is going through this massive digital transformation, using analytics, AI, you name it, to make smarter, faster, and way safer decisions. And you can see it plain as day in the training catalog. I mean, look at this. Courses on data analytics, digital surveillance, all sorts of software. And pay close attention to that last one, seismic analysis for energy and CCUS. See, it's not one or the other. Being fluent in digital tools is now the universal language for the entire industry, old and new. Okay, the second accelerator isn't so much about software and code. It's all about execution. We have to remember, these projects are unbelievably complex, and the stakes are sky high. One little mistake could have huge consequences, both financially and for the environment. So, you absolutely have to get the management side perfect. It's just non-negotiable. So it makes perfect sense, right? You see a whole bunch of courses focused on things like project de-risking, uncertainty management, and how to handle all the tricky legal and commercial stuff. It's not enough to be the smartest engineer in the room anymore. You also have to be a master of risk, of money, and of making sure everything runs like a well-oiled machine. Okay, let's bring this all home. We've looked at the foundational science, we've seen the huge pivot towards sustainability, and we've talked about the digital and management skills that are changing the entire game. So, when you put all those pieces together, what does the Energy Pro of tomorrow actually look like?
Well, here's the blueprint. First, they're still grounded in those core sciences, geology and engineering. That's the foundation. But on top of that, they are totally fluent in digital tools and data. They're also incredibly versatile. They have to be, able to use their skills for getting resources out one day and putting carbon back in the next. They are laser-focused on sustainability and managing risk. And maybe the most important thing of all, they never stop learning. They have to be lifelong learners because this industry is just evolving so fast.
And that really is the main takeaway here. This isn't a revolution where everything old gets tossed out. It's an evolution. It's about taking decades of experience, all that incredible expertise that was built up over time, and aiming it like a laser at the biggest challenges we face in the future. So when we look at this blueprint, it's pretty clear what it takes to be an expert in today's energy world. But it kind of makes you wonder, doesn't it? This combination of skills, deep foundational knowledge, the ability to adapt on a dime, a data-driven mindset, is that just the blueprint for an energy expert? Or is it maybe the blueprint for the kind of problem solver we're going to need for all the big challenges that are heading our way?